Hello everyone. In this video we're going to be solving an exponential equation from 101 problems in algebra. We have 10 to the power x plus 11 to the power x plus 12 to the power x equals 13 to the power x plus 14 to the power x. So it's a pretty interesting problem because we have consecutive numbers 10, 11, 12, 13, and 14, and we're going to be looking for x values that satisfy this equation. So this looks like a hard problem, doesn't it? Let's see how we can handle it. First of all, notice that all the numbers on the left hand side are less than 13, which means they are also less than 14. So here's what we're going to do. And by the way, I did not include a graph here because the graph doesn't look good. You can try to graph it, but it's not going to come out very good. Anyways, so let's go ahead and divide everything by 13 to the power x. Again, you may question why I'm not using the highest power. There's actually a good reason behind it, which you'll see in a little bit. But also explore what happens if we divide everything by 14 to the power x. So let's go ahead and divide it. 10 to the power x divided by 13 to the power x plus 11 to the power x divided by 13 to the power x plus 12 to the power x divided by 13 to the power x. On the right hand side, I'm going to be getting 1 plus 14 over 13 to the power x. Awesome. Now, if you look at each of these terms, you can actually go ahead and write them with a common exponent using properties of exponents. So I can write this as 10 over 13 to the power x, and then 11 over 13 to the power x, and then 12 over 13 to the power x. Same thing goes on the right hand side, 14 over 13, which I already did. Okay, so let's just repeat that. Now, one thing that I want you to pay attention to, if you look at the left hand side, all the bases, 10 over 13, 11 over 13, and 12 over 13 are less than 1. Do you agree? 10 over 13 is less than 1, 11 over 13 is less than 1, and 12 over 13 is less than 1. Great. What does that mean? We'll talk about it. And on the right hand side though, there's a different story. 14 over 13 is just greater than 1. You can see that, right? And I'm adding 1 to it. So what does that mean? What does all this mean? Whenever you have an exponential function like y equals b to the power x, in this case b is a constant, x is the variable, so you have to think about it if there are two cases basically. Obviously, we're not talking about b equals 1 because that would be kind of meaningless. That's just going to be a constant function. I mean, we can talk about it, but that's not going to be very interesting because y is just going to be a constant, right? But what if b is greater than 1? Then you're going to have an increasing function. So instead of y, let's just go ahead and replace this with f of x. And y and f of x are basically interchangeable, but in this case, f of x is going to be an increasing function. Example, y equals 2 to the power x. Makes sense? If b is less than 1, but of course we want b to be greater than 0, because when b is negative, think about a function like this, right? It's just going to jump up and down like crazy if x is an integer. And if x is not an integer, it's just going to be super crazy. Think about it. All the powers of -1 in the complex world. Think about something like -1 to the power 7 over 3. You're basically talking about the cube root of -1 in the complex world raised to the 7th power. So it's going to be really crazy. That's why we want to restrict our function to positive bases. That's why b needs to be between 0 and 1 if it's not greater than 1. And in this case, f of x will be a decreasing function. Make sense? So in two cases, increasing and decreasing. And this is what they look like. Increasing function is going to look like this, and the decreasing function is just going to look like this. Okay? Cool. Now, what happens on the left-hand side? All of these are less than 1. So this is a decreasing function. This is decreasing, and this is decreasing. Now, what happens if you add decreasing functions? You get a decreasing function. Why? Let's talk about it. If you have something like y equals f of x plus g of x, suppose f of x and g of x are both decreasing, which means their derivatives are both less than 0. That's what decreasing means, right? On an interval. So when you differentiate a sum, you basically differentiate each term in the sum. So if these are both negative, their sum is also going to be negative, which indicates that the sum will also be a decreasing function. Make sense? In other words, the left-hand side is a decreasing function, while the right-hand side is an increasing function. What's that supposed to mean? You have a decreasing function like this, and then another function that's increasing over. They're not like that, but what happens is they are supposed to increase at a, did I say increase? Okay, I meant intersect at a single point. And this is probably not a good example, because if your function doesn't always increase and decrease, then you're not going to see that single intersection point. So, to keep a long story short, there's only one solution to this equation, which we found out by dividing both sides. Obviously, if you didn't do that, how could you tell that they're acting differently? Right? You could look at the derivatives and see how they behave, but in this case, both sides are increasing, but, that's just going to be kind of crazy. Obviously, the right-hand side is going to grow a little differently, but again, without dividing, it's really hard to tell. So, we're going to have a single solution, but what is that solution, right? That's the most critical part, and we don't really have an algebraic way of finding it, as far as I know. You can do maybe some approximations, but the fact is, I would try some basic values such as x equals 0, x equals 1, x equals 2. Can x be a negative number, right? That's going to be a good question. If x is negative, then you're going to be talking about something like 1 over 10 to the power y, where y is negative x. And then we're going to be adding all these numbers, and it's going to be a different story. And I don't know if you can tell, but the thing is, this is going to have a single solution, so I might as well start with positives, right? Because negatives are going to be like adding fractions. Think about it. If x is negative 1, for example, 1 over 10, 1 over 11, 1 over 12, or even their powers can never give me something like this. Think about it. Like, can you ever get something, an equality from here? Even if you raise them to different sides, different powers, it's not going to work. So we're going to test. If we had the same number of terms on both sides, like this, let's just pretend that this is gonna, work for our purposes, and obviously it is going to, right? In this case, I could go with 0. You know why? Because 10 to the power 0 is 1, so it's going to be 1 plus 1 plus 1 equals 3, and that's going to be true on both sides. And if this equation has a single solution, it has to be 0. But we don't have that, so what do? Well, we test it out. X equals 0 does not work. X equals 1 does not work. But x equals 2 works. And that's the only solution. And this brings us to the end of the video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.